Hello there, my name's Jacob Peroni, and this is my survey presentation on search engines for CAP 6776 information retrieval. So here's the outline of the presentation. It's going to go as follows. I'm going to give an introduction of the first search engines. I'm then going to give an explanation of the search engine process, and I'm going to conclude with an example discussion of a popular search engine that's widely used today. So Archie was really the first search engine made, and it was a downloaded directory of all anonymous FTP website documents and files from computer networks stored into a searchable database. Gopher was then a document retrieval protocol that was similar to Archie, but also indexed plain text documents and could search by the title of the documents, but not the contents. Veronica and Jughead were able to solve that by creating plain text indexes based on the content within the HTML document being indexed by Gopher. Wandex was the first website search engine that combined Gopher and a plain text referencing program into one inclusive package. Wandex used an index created from the World Wide Web Wanderer indexer. The search engine web crawler could search entire pages and was the first to offer any full page, full text search, which is similar to what modern day search engines do now. Before this, though, search engines could only index page headings. And then you see the big three, Google, Yahoo, and Microsoft, are now the modern day search engines that are widely used nowadays. Every search engine is based on the information retrieval process. So the search engines will go and collect information and indicators about a page's contents, and then they'll store them on their own databases, and then use search algorithms to index them and return the results to the user. So the retrieval is a combination that consists of a user agent, databases, and search algorithms. So user agents are also called crawlers, and they gather data from the web. So the crawlers identifies and looks at every URI and URL on the internet and extracts the data to the databases. The user interface of the search engines are connected to a system of databases which store the data points about each URL, as the search engines typically operate on a URL to URL level. The databases used are similar to those in Gopher or Wandex, but the number of data points, as well as the crawler's ability to search but also to render HTML documents, has drastically improved since the first few iterations of search engines. There are many search algorithms out there, such as list search, tree search, or SQL search, just to name a few. Tree searches have typically been more successful for web-based searches, but they're not the only successful algorithms used in information retrieval on the web. Typically, tree search works by searching the database from broadest to narrowest, or vice versa, and it's under the pretense that the database is like a tree, and a single piece of data can connect to multiple data points that are related. So for my example discussion, I'm going to be talking about Google search engine, specifically crawling and indexing, and one of the search algorithms used. As a simple overview of the Google process, the crawlers will go out and gather the contents from the internet and store them on indexes on Google's servers in the databases. Then the search algorithm can go and look up the index of the keyword, which will direct to the database that contains it. And then those results are ranked and sent back to the user as a web page with hyperlinks that go to those web pages. So Googlebot is the web crawler that Google uses, and it gathers the information from publicly available web pages. It starts at a website, and then it'll follow every hyperlink on that page, and then it'll follow every hyperlink on that page, and it'll keep repeating that until it's gone through every hyperlink on every page. So when the crawler visits the page, it'll load the contents into a database and then once the page is fetched, the contents will get loaded into the index, and the index is a huge database of words and where they occur on different web pages. So that way when the search algorithm goes with a query, it can match the keywords to the index and then return the results back. So the PageRank algorithm is one of Google's search algorithms. It's being presented here as it's the most known, but it's not the only one that Google uses. So PageRank works by counting the number and quality of links to a page to determine an estimate of how important the website is. So the assumption here is that more important websites likely receive more links from other websites. PageRank algorithm outputs a probability distribution to show the likelihood of a click on any particular page. PageRank transfer from a given page to an outbound link on the next iteration is divided equally among all outbound links. So for example, if there's say 4 pages and page 1 has outbound links to pages 2, 3, and 4, then the page 1 PageRank value is divided by a third and transferred to the other pages on the next iteration. More information about the PageRank algorithm, as well as an actual implementation in Python, can be found at the source below. Ranking is done by relevance score. So PageRank assigns a score based on matching search criteria of the search query. And the higher the score is, the more likely it will be the top result that's sent back to the user. PageRank scores are recalculated after each web crawl, which helps keep the results relevant to the searches being done. So now we're going to talk about the second most widely used search engine in the modern times, which is Yahoo Search. So Yahoo did not build a search engine from the ground up as Google did, but they instead used the other technologies that it purchased in the early 2000s. Before that time though, Yahoo received search results from either Inktomi or Google themselves, and they ended up buying Inktomi, but it was speculated that Yahoo would buy Google. After buying Inktomi, Yahoo then bought Overture, which was a pay-per-click advertising company who had just bought Alta Vista, which was one of the first search engines created before 2000. Then in 2004, Yahoo launched its own search engine called Yahoo Search, which many thought would just be a rebranding of either Alta Vista or alltheweb.com. Alltheweb.com was owned by Overture, which Yahoo acquired. What Yahoo ended up doing was mixing together all the features of the software that they owned. They had Inktomi and Alta Vista's crawlers, which were very fast, as well as having alltheweb.com and Alta Vista's ranking algorithms, which were pretty good also. They ended up just mashing all of those together. So Yahoo Search is not vastly different from Google, except from that aspect mentioned, but both search engines use many factors to determine the relevance of a search query, and the results of that analysis are what is shown to the user. When Yahoo Search first came out, it had an emphasis on the home page of a given site, and not on inbound links or other site pages. But that has since changed to ranking towards inbound links. It does rank inbound links differently than Google though, and as a result, the Google results tend to be lower, which Google even states is because they only show a snapshot of the relevant links, whereas Yahoo shows all of them regardless of relevance. So now we're going to look at the last example discussion, which is MSN Search, or as it's now called, Microsoft Bing, which is the third most popular search engine today. So MSN uses neural networks, which back in 2005, when it came out, it was one of the only ones that was using those. What MSN Search was doing is having it learn from the inputs given to it. The search engine could be told that a website is authoritative, So when the user performs a search and goes to that site, the search engine can learn why it's considered authoritative. And it can then apply that learning to other sites that might also be authoritative. The engineers now have a way to train the search engine to determine what is relevant and what is not, which ends up being a big advantage for them. This allows the system to improve itself over time. The ranking system for algorithmic systems generally are finite in size, while the ranking system for MSN would expect to grow as the neural network grows. The MSN engineers have found a way to shortcut the requirements for ranking by saying that there may be X amount of factors to determine page quality, but only a significantly less X amount of factors are used in this category. Therefore, those same significantly less amount of X factors associated with this category can be used. On paper, this search engine looks to be able to adapt faster to changes on the web because it would not have to wait for an algorithm change. It only has to learn the change and then apply it itself. As of August this year, Microsoft has created a neural network model called MEB, which powers the Bing search engine, and which takes a unique approach to determining relevant pages to a user query. Neural networks use weighting of features to come to a decision, and that technique is also applied to determine page relevancy. Normally, neural networks rely on thousands of numerical features to make decisions, but the MEB model uses billions to decide whether web content is relevant to keywords searched in Bing. Microsoft also states that MEB model can determine if a web page contains relevant information, even if it doesn't have keywords that are identical or similar to the search query. It is able to achieve this by using binary features instead of numerous features. As an example, Microsoft stated that MEB correlated Hotmail with Microsoft Outlook, even though they are not close in semantic meaning to each other. MEB was able to pick up on a nuanced relationship between them, which was that Hotmail was the email service that was Microsoft used way back when, and it had its name changed to Microsoft Outlook. Here's a list of the sources that were used for this presentation. If anyone wants more information about the search engine process or particularly how any search engine works, more information can be found at these links. And thank you all for your time.